Welcome to this video. In this video I will be showing you how to train a custom YOLO V4 detector on Windows. I'll be showing you the process for both YOLO V4 and YOLO V4-tiny. It's similar, both these processes are very similar with only a couple of changes. So I'll be giving a link to both these articles in the description below. So okay, let's just jump into it. Okay, so first let's train a custom YOLO V4 object detector on Windows on your local machine. So if you have a good GPU, so you won't have any problems running YOLO V4 object detector. But if you have an old GPU that does not have a very good compute capability, you can train using YOLO V4-tiny. Obviously this will be much faster than that. However, the accuracy for this is a little less than YOLO V4. I have compared these two in one of my articles which I have posted earlier. So I'll also be giving a link to that, YOLO V4 versus YOLO V4-tiny. Hopefully that will clear your doubts. Okay, let's begin. These are the steps that we will be using. If you've followed my previous steps for training this on a Google Colab notebook, all the steps are very similar. Okay, so now first step, we will be creating a folder on our desktop. Create YOLO V4 folder on your desktop and then create a training folder inside it. Head over to our desktop, go inside this, create another folder named training over here. This is where we will be saving our weights after the training process. So okay, now next, open command prompt and navigate to the YOLO V4 folder. You have to navigate to this folder, YOLO V4. Just open a command prompt over here and navigate to it, or better just type cmd over here in this folder. This is automatically open this in this folder. For the next step, create and copy the Darknet folder containing the Darknet.exe, the executable Darknet file, into the YOLO V4 folder. Now we've created this in another video. I'll be giving the link to that as well, as this step is a little bit tedious. So I've made a separate blog and video on this. You have to go and check it out. This might take some time, but this is the most important part of this tutorial. Once you've created this Darknet file, you won't have to create this or run the make command again and again as we did in the Google Colab notebook. So I've shown you how to install YOLO Darknet on both Windows and Linux, and also how to use YOLO commands on Windows and Linux. This will help you. So you can just head over to this article, install. This is the process using CMake. Install it. We get a Darknet master folder from it. Now all you have to do is copy that Darknet master folder that we got from that article after creating the Darknet.exe file. Just copy this to the YOLO V4 folder. I have this over here on my desktop. You can copy this to the YOLO V4 folder and just rename this as Darknet, because I've given this Darknet path in the later commands. So okay, next step, create and copy the following files which we need for training a custom detector. If you've seen my previous videos, you'll know that these are the 4 main files that we need to train any custom object detector. So first is obviously your labeled custom dataset, your dataset images with its labeled files. So I have all these files over here. I've also uploaded these on my GitHub over here. I have uploaded my labeled custom dataset on Kaggle. I've given the link to that down here at the bottom. Over here you can download this from here. Download the zip file, unzip it. Okay, and I've uploaded all the rest of these files over here in the YOLO V4 folder, as you can see. So just download those files. I have those over here. Now this is the obj dataset folder that I was talking about. Download this from Kaggle, unzip it, and just copy this folder directly to the YOLO V4 folder over here. I've also given a brief overview of how to label your dataset over here, as I've done in many of my previous tutorials. So okay, now we've copied the dataset into the YOLOv4 folder. Copy the custom config file. You can copy these files, then the obj.data and obj.names files. This is how these files should look like. The only change here over here is in the obj.data file. If you remember, for training online using Google Colab, we had given a path for my drive over here. You can simply give the path to the training folder. So we'll be copying all these files inside the YOLOv4 folder itself. That's it. Now we'll be making all the changes in it as mentioned over here. Let's begin. Okay, so the first change that you have to make, as you can see over here, is change line batch to batch 64. Let's open this file. I've already made a few changes. Let's make a few other changes for training on your system, on your local machine. So okay, change line batch to batch 64. Okay, that's done. Change line subdivisions to either 32 or 64. Let's start with 32. Okay, the reason I'm setting my subdivisions to 32 or 64 is because I don't have a very good GPU. Now you have to know what this batch and subdivisions represent, what they mean. So I have given a note over here just below this. So if you read batch, if we enter 64, that will mean we are loading 64 images for one iteration. And if we set subdivision to 8, so that means it has been split into 8 mini batches, this batch. So 64 divided by 8, that is 8 images per mini batch, and these 8 images are sent to the GPU for processing for every one iteration. So obviously, since we have 8 mini batches, this will be repeated 8 times until the batch is completed. That is the first one, and then it will start another iteration with 64 new images. So you can set batch to 64 and set this to 16 or 8. That will obviously load more images for processing in each iteration. But again, since I have a very old GPU, I won't be setting this to 16 or 8. I'll just be setting this to 64 and this also to 64 or 32, whichever way I see my GPU is performing well with the memory it has. So okay, choose your batch and subdivisions carefully. You can try altering these to see which training process is quicker and doesn't give you any memory error. That will train it much faster. Okay, now next, set network size, width and height to 416. That's already set over here. Next, change line maximum batches to classes into 2000. I have two classes, so that will be 2 into 2000, 4000, but the minimum should be 6000. So that's what I will set it to. Next, change line steps it to 80% and 90% of that. These two, I've already done that. Max batches steps to 80 and 90% of that. That is 4800 and 5400. Okay, moving on to the next step. Change filters equals to 255 to classes plus 5 into 3. That will be 2 plus 5, 7 into 3, 21 in each of the 3 convolutional layers before each of the YOLO layer. Okay, so and then also change line classes equals to 80 to your number of objects in each of the 3 YOLO layers. I have 2 classes, so I'll be changing this to 2. You can go at the bottom, you'll find the last YOLO layer. I have changed the classes over here from 80 to 2 and the filters just above it to 21. Same for the second last YOLO layer, go above, change the classes here, the filters here to 21. Again, go to the first YOLO layer above, Again, change classes here to 2 and filters here to 21. That is it. These are the basic changes that we need to make in order to train a custom YOLOv4 object detector. Now obviously there are a bunch of changes that we can make in this CFG file, but these are the basic requirements that we need in order to train a detector. Okay, so that was it for the CFG file. Now next, for the obj.data and obj.names files, make sure that these values are the same. This should have all the classes names written in it. That's fine. Obj.data, again you can check it from over here as well. The number of your classes, the path to the train.txt file, this is the path to the test.txt file, obj.names files which we saw previously, and finally the backup folder where we will be saving our weights during the training process in this folder that we created in the first step. Okay, so that is it. Moving on to the next step, just simply copy this process.py script file which we downloaded from my GitHub to this folder. We've done that. You don't need to make any changes in this process.py script file. I've already made all the required changes for you, so you're all set. Okay, this is the Darknet folder which contains the darknet.exe file over here. This is the Darknet executable and all the other files. Okay, so alright, moving on to the next step. Now we have a backup of all these files over here, so if anything goes wrong you can just come back to these. Now next step, we'll be copying all these files from the YOLOv4 directory to the YOLOv4 Darknet directory. You can do this using File Explorer just like this. What you have to do is, first we have to do is clean the data in CFG folders. Again, except the labels folder inside the data folder, which is required for writing label names on the detection boxes. So what you have to do, go inside Darknet, go inside this CFG folder, simply select all and delete this. But before we delete this, I just want to show you that we have all the custom files over here. The YOLOv4 custom file, the official file looks like this. So we downloaded it from my GitHub and I've made all the changes over there. You can also use the custom files from over here depending upon whatever you're training it for. Okay, so just select all this, delete it, go back to the Darknet directory data folder. You can again delete all these files, just don't delete this labels folder. This is required, so don't delete this labels file. That's it. Next step, we have to copy all these files. Copy the CFG file, the edited CFG file, to the darknet.cfg directory, obj.names and obj.data to the data folder, and process.py to the Darknet root directory. So okay, let's do that. Okay, you can copy this, go inside Darknet, CFG, copy it here, copy these two files inside the data folder over here, and finally copy the process.py script file over here itself. Okay, I already had this file, but you have to copy it. Okay, we have this over here. Okay, so moving on to the next step. And now this next step is just optional, you can skip this. This is just for those who like using the command prompt and coding. So this is basically all these steps that we have done, cleaning the data and CFG folders and copying all these files using a command prompt. So you can use this too if you like. Okay, Now skipping these steps, okay, moving on to the next step, number 6. Run the process.py script file to create train.txt and test.txt files inside the data folder. So both these text files have paths to all of the images, where test.txt has path to 10% of the images and train.txt will have paths to 90% of the images. Okay, and this should be the current working directory. So go over there, change directory to Darknet. That's it. You can simply run this command. Okay, that's done. Now you can confirm this using the next command, dir data. Now just one thing, I have not carried out one step. So just to show you, if you have any errors, you can simply confirm it. Okay, let's use this command. As we can see that both these files are empty. So obviously we made some mistake. So basically the process.py script file requires the dataset folder. Let's open it and show you. We need this directory, the obj dataset folder, that will create these two files and write the path in it using .jpg format. So only use .jpg format if you can, because that's what I have used in this process.py script file. If you want to use any other format, you can make the changes here accordingly. Okay, so the step that we missed out earlier was this one, as you can see, and the obj folder to the data directory as well. So that is what we missed earlier. Just copy this, go back into this folder, paste it. These are empty. Okay, so it has been copied. Now the process.py script file will work. You can delete this or just leave it as it is. It will just override these. Again, run the process.py script file, confirm. As you can see, these files have some content written in it. You can again open these and confirm. So this will have, since I have 1510 images, 10% of that is 151. So I have that over here, and so this will have 90%, that is 1359 over here. Let's go down to the bottom. Okay, so that's okay. So moving on to the next step, after step 6, that is step number 7, download and copy the pre-trained YOLOv4 weights file into the YOLOv4 Darknet directory. So we will be using transfer learning here. We won't be training from scratch. Okay, so you can download it using this link, any of these two links. You can download these pre-trained files and copy it to the YOLOv4 Darknet folder. And that is what we will be doing once this is downloaded. Okay, so it is downloaded. You can copy this and just paste it over here in the Darknet folder. That is it. Moving on to the next step, the training step, step number 8. Again, check that your current working directory is this, and now we can use this command to train our custom detector. Now for best results, you should train the detector until the average loss is less than 0.05 if possible, or at least constantly below 0.3. So okay, just run this command. So let me quickly explain what this command does. This is a darknet.exe, the executable file. Detector train, this is the command to train. Now this is the path to the obj.data file to the CFG file, our custom CFG file. This is the pre-trained YOLOv4 weights file we downloaded in this step, and this is don't show. You can remove this if you want to see the training graph while it is being trained, but I've set this to don't show. And next, this MAP parameter, which gives us the mean average precision. Obviously we will use this parameter to finally stop the training process. So the higher the MAP, the better it is for object detection. So whichever weights file gives us the better MAP, we will use that weights file for our object detection purpose. Let me show you. Now it is starting the training process. Now since I have an NVIDIA GeForce GTX 1070 GPU, it is a 5-year-old GPU, so the training process for YOLOv4 will be very slow. But obviously, since this is on your local machine, you won't get disconnected, so you won't lose any progress over here. I've stopped the training process. Just to show you one more thing, I will be removing the don't show parameter as I discussed earlier, and we will see it will show us the progress chart. So this chart will keep on updating as this training progresses. Okay, let's stop this now. Since I have stopped this training, this won't automatically stop itself, but if you have to stop this training for some reason, you have to turn off your computer, or you have to come back later some other day and restart training from the last saved checkpoint. Just make sure you have at least trained it for 100 iterations, because this saves weight files every 100 iterations, minimum 100 iterations. So I've also written this over here. The weights are saved every 100 iterations as YOLOv4 custom_last.weights in the training folder. So to restart training, we will be using this command, which is the same as this command, except for this parameter. Instead of the pre-trained weights file, we will now be using the weights file that was saved last. Okay, now I have stopped this after 110 steps. So this has already saved a weights file over here as YOLOv4 custom_last.weights file. This has been saved once after 100 iterations. Now what I will do, I'll continue this from over there using the last.weights file. So okay, as you can see, it has started training from step 101. So okay, this is how we can restart training, and as you can see, we see the average loss over here. This starts out very high, but after 500 600 iterations it will start to drop, and once it has reached below 0.2, now ideally around 0.05, that's when you can stop the training process or let it train to the number of maximum batches that you have set, and see what the MAP for each weights file is. Okay, so I'll start the training process again and then come back to you once all the 6000 iterations are done and we have our final weights file, best weights file for us. Okay, so I'm done with the training process. These are the weights files that are saved after the training is done. This will save these weights file every 1000 iterations like this, and then 3 other files as I mentioned earlier. Last weights is saved every 100 iterations, and then final weights at the very last, and best weights file. And my final average loss had reached around a little under 0.1. So okay, now we're good to go. Now to check the performance, what you can do, is check the training chart. Now since we are training this on local machine and you don't have to disconnect your system and you won't lose your session, you can train these 6000 iterations continuously. You will see this will have a chart.png file over here. This will have the progress saved in it. This will look like this. As you can see, the MAP over here, and we can find out which weights file has the best MAP and at what iteration, so we can use that weights file for detection. Moving on to the next step, you can also check the MAP using this command. Just copy this command. Okay, so let's clear this first. Paste this command. You can replace this 1000 which whatever weights file you want to check the MAP for. I'll check this for 4000 weights file and let's see the MAP for it. So okay, as you can see, this has detected the MAP for it, and this is the mean average precision at 0.50, that is 0.98, that is 98.13%, which is quite good since this was for only step 4000. That's good. Now let's test it for another weights file. You can test this for all the files and see which one has the best MAP. I'll test this for the best weights file. Let's see for the what the MAP for it is. Yes, as you can see, this has 99% accuracy, more than 99%. 4000 weights file had 98.13, this has 99.14. So this might be probably somewhere between 5000 and 6000. So there is a chance that MAP can also decrease after a few thousand steps and then increase. It gradually increases over time. Okay, this is how we check the MAP and use the weights file that has the best MAP. Now for my trained weights files, I know that this best.weights file has the best MAP, so I will be using this for testing purposes as well. Moving on to the next step, which is the last step of this tutorial, testing our custom object detector. For that, again, making changes to our custom config file. As you can see, we have to make these two changes in our custom config file. These are the backup files, don't make the changes over here. This is the file that we had been using in our commands, so we have to change this to 1 and 1. As you can see, we already have this mentioned. This is for training, this is for testing. You can simply uncomment these and comment out these, or just change this to 1 and 1. Close this. Now running detector on an image, upload an image to a folder named mask test images. Okay, I have this mask test images folder on my desktop where I have uploaded a few images for test purposes. As you can see, test 1, test 2 up till test 11. So these are the images. We'll test a few of these, and I have a few outputs here, but we'll use another name. Now just let's run this command. So let's quickly go through the usage of this command. Again, darknet.exe detector test, this is the command. Part 2 obj.data, your custom CFG file, the CFG file that we have used to train our weights files. You have to use that very CFG file over here. This is the part of the weights file that we will be using. I'll be using the best weights file. As I've mentioned earlier, this has the highest MAP, 99.14%. and then next path to the image file that we will be testing. And finally, this is the threshold parameter. You can set this to whatever you want to set your minimum detection threshold to. This is the minimum accuracy required for object detection. So right now it is at 30%. You can change this to 0.4, that is 40%, or 0.5, 50%, and so on. Let's run this command. Now I have this as test1.jpg, which is this file. Okay, so just run this. Now what this command does, it will give you an output over here, and then it will also save an image in this Darknet folder over here as predictions.jpg. This over here, let's see what it gave us as output. So as you can see, it has detected this mask with 100% accuracy. That was very good. You can close it. You can also see that it will save this predictions.jpg over here as well. So what you can do is simply copy this predictions file as this output image.jpg. You can give whatever name you want for each file. So I've copied this into the same folder as the input folder as output image. You can see I have this new image over here as output image, and similarly let's run it for another image. I'll use this one, test6. It has both these classes, one is with mask and the other is without mask, so this will be a good testing image. Again the command is same. This will give us the output and save the output in predictions.jpg file. As you can see, it is showing us both these classes over here, and it has detected both these classes here, this one with 100% accuracy, this one with 98%. So that is very good. You can stop this. Again, you can save this as output image. Since we used it for test 6, you can copy this. You will see now we have this file over here. Okay, now let's test. Okay, that's done. Now we can move on to the next step, that is running detector on a video. Now upload a video to a folder named mask test videos, and we will be running detection on that. Close this. We have this mask test videos folder over here, and I have a bunch of these videos for testing purposes, so I'll be using one of these. Let's use the first one, test.mp4. So the girl had the mask on, now she removed the mask, so this should give us the output for both the classes. Okay, just use this command. Now let me quickly explain this command. This is the same detector demo. Demo is used for videos, like test is for images. Again, this is the obj.data path, your custom CFG file path, your weights file path, then the path to the input video, and then the threshold, the minimum object detection accuracy required. I'm setting this to 50%. Anything below that won't give an output. So and finally, this is the output file name. You have to set this in order to save an output file. If you don't give this parameter, it will still run detection and give you the output on a video over here, but giving this parameter ensures that this will save a file named output.avi inside this very folder. I already have a bunch of outputs here as well, so I'll use a new name let's save this as final result.avi. We don't have to make any other changes. So again, depending upon the capability of your GPU, this can take a while. If you have a good GPU, as I mentioned earlier, this process will be very quick. Okay, so the detection is done. This will save an output file here. We gave the name as final result.avi. Let's run this. So let's see both the classes. Okay, so as you can see, it has given the correct output for both the classes. We can move on and run the detection on another video, preferably where we have two different classes. Okay, this one we have a video where we have both the classes at the same time. So let's run detection on test6.mp4. and save it as final result 6.avi. Okay, so that's done. Let's look at the result. Okay, so the result for this is also fine. So okay, this is how you run detector on a video and save it. Now this step is done, we can move on to the next step, which is the last step of this entire tutorial, that is run detector on a live webcam. Basically the command is the same as the previous one. Now what I've done is simply remove this video file parameter, this entire parameter from over here. I haven't given any input video. You can remove this. So we only have Darknet detector demo, obj data, CFG file, your weights file, and finally the threshold, and there is it. You run this and this will run detection on your camera. So as you can see, the detection for this is also pretty good. This is detecting my mask right now with almost 70 to 80% accuracy. So obviously this will depend upon your GPU. Moving on to the next part of this video that I had mentioned earlier, I will also be showing you how to use YOLOv4 V4-tiny to train a custom object detector. Again, you can just head over to this article. Both these two processes of training YOLOv V4 and YOLOv V4-tiny are similar with a very few changes. So alright, let me just quickly explain what the changes are. I've already made all the changes to the folder names. As you can see, I've changed the YOLOv V4 folder to YOLOv V4-tiny. This is just so that you can easily differentiate between the two, and that's it. However, there are very few differences in both these two tutorials. One is the custom CFG file that we will be using. For the YOLOv4 tiny detector, we have a different YOLOv4 tiny custom CFG file. So I have uploaded this on a different GitHub repository. You can use this one. Obviously, I have given the link here in this article for YOLOv4 tiny, and that is it. So now the next difference is in the CFG file. Obviously these changes will be similar. except you have to make these two changes only 2 times, since YOLO V4 Tiny has only 2 YOLO layers, and YOLO V4 custom, the one we did previously, has 3 YOLO layers. So as you can see in this CFG file for YOLO V4 Tiny, this tiny custom CFG file has only 2 YOLO layers, so you need to make these changes over here only 2 times as compared to previous YOLO V4's 3 YOLO layers. Okay, so that's it. Now these files are the same, the process script file will also be the same. Now the next change here in this tutorial is this pre-trained weights file. For YOLO V4 we used a pre-trained weights file that was trained up to 137 convolution layers. However, this YOLO V4 tiny pre-trained weight file will be trained up to 29 convolution layers, so you can use this for transfer learning. You can download this from here, and just like we did for the YOLO V4 pre-trained weight files, you can copy this to the Darknet folder, and we will be using this in the next command. As you can see, these files and then the tiny custom CFG file that I mentioned earlier, and again the rest of the process is the same. You can restart training using the same command here as well. YOLO V4 tiny custom last weights will be used here to restart the training process. Okay, so and again check performance, this is also the same. You can check the MAP, test your object detector, again make changes, set batch and subdivisions to 1. Okay, again now next step, running detector on images, videos and live webcam. All these commands are the same. So okay, just know that the training process for YOLO V4 Tiny will be much faster than YOLO V4. YOLO V4 Tiny weights file, as you will see over here, is only around 23 megabytes each of these files, as compared to YOLO V4's weights file, which is around 250 megabytes. So, and also the detection on a good GPU using YOLO V4 Tiny will be much faster. The video detection will be much faster, and running detection on a live webcam is much better using YOLO V4 Tiny. Okay, that's it. This is how we train YOLO V4 and YOLO V4 Tiny. You will find all the links down below in both these tutorials for YOLO V4 and YOLO V4 Tiny. Don't worry, I'll give all the links for all the articles and GitHub repositories I've mentioned in the description. And okay, that's it for this video on how to train a custom object detector using YOLO V4 and YOLO V4 Tiny on your local machine Windows system. So if you've enjoyed this video, please click on the like button and make sure to subscribe to this channel. And okay, I'll see you in the next one.